Good morning, everybody, and welcome back to Next Door NetAdmin. Last week, we spoke a bunch about OSPF in terms of what it is and why you would want to use it. Today, we're going to take a look a little bit at the how. It's going to be basic right up front. It's going to be pretty basic. But I'm also going to talk about some of the things that you really should know that may not be immediately obvious. So let's just dive in and take a look at this on our development machine here, as usual. I have a diagram of what we're going to be looking at, and I have the basic configuration that's relevant for what we're doing. We have two routers, R1, R2. I've written it out here as router 1 and router 2, standard notation. And each one of these has three interfaces. We've got a gigabit 00 with 10.0.0.1 and .2. It's a /30, meaning that we're treating this as a point-to-point network. But it is Ethernet, so that's an important point. And then their second gigabit interfaces, 0.1, are going to be on two different subnets, 192.168.1 and 192.168.2, both of them /24. You'll notice I've also configured two loopback interfaces here. In standard, it's a standard example that you make it just all the same number, similar to router 1 and router 2. So you have 1.1.1.1 and 2.2.2.2. Now, obviously, I know that 1.1.1.1 is an actual service nowadays. So these may not be the addresses that you want to use in practice. This is an example. Just to be clear on that, so I don't get somebody, hey, you know Cloudflare yet. I know this. We're just doing this as an example. Don't kick me for it. So, why do we have loopback interfaces in the first place, other than providing another network interface that we can test with, essentially? Well, a lot of this has to do with the concept of a router ID. In OSPF, when a router is sending out the link state advertisements, or LSAs, to tell everybody else what links it has that are up, down, and what addresses they're carrying, all of this is identified with its router ID, which means that you don't want routers to have the same router ID. There's a few ways that you can do this. By default, OSPF will pick the highest numbered IP address configured on the router that is live at the time OSPF starts. You'll notice there's a lot of caveats in there. It's the highest IP address available at the time OSPF starts. If we were looking at router 1, that would be 192.168.1.1. That would become the router ID. What if we added another interface and made it 192.168.250.1? Well, that becomes the highest IP address. But it wouldn't change the router ID until OSPF restarted. Which means if the power goes out and it comes back on, suddenly your OSPF router ID may have changed. And that may not have been something that you had planned for or wanted to have to deal with. So it's preferred if you have something that is immutable, something that's not going to change regardless of what other configuration changes on the router. Another alternative is to actually use a router ID command, and it would look something like this. you can use a router ID command. If you do that, that becomes the router ID used by OSPF, but only if OSPF hasn't started yet. If it's already started, again, the router ID will not change, and so you'll have to restart OSPF with a command or by restarting the router in order to get it to use the new router ID. Now, the router ID, I mentioned last week, OSPF uses dotted decimal notation a lot of the times, but it's not actually an IP address, so you could just as easily make this something like so, and it would treat it perfectly acceptably. But there's a reason why we don't, and there's also a reason why I didn't put in the router ID command. That is because if we go back and look at our drawing again, there's another option here, the loopback interface. If you have a manual router ID command configured, that takes priority always. But in between a router ID hard-coded and just the highest IP address on an interface somewhere, OSPF will treat the loopback interface as a separate class of interface because it is administrator controlled and it's not dependent on other networks that are connected to the router. If you have a loopback interface, OSPF will use that address as its router ID, and it'll just go with that because it'll always be up. It doesn't depend on the network being up or down. It doesn't depend on DHCP or anything else. It's just there. Now, if you add more than one loopback interface, it's going to use the highest IP address on one of those loopbacks first, before it goes to any of the other IP addresses. So, yes, it still has the problem of if you add loopback 1 or loopback 2, all with different IP addresses, and then restart OSPF, your router ID might change. But typically speaking, that's going to be a lot less common and a lot less likely than one of your other network interfaces changing. Because why do you need more than one loopback interface? And it's only going to be there because an admin specifically configured it. So it is very typical to have a loopback interface configured so that you have a stable router ID. And there's other considerations that go into it. If you have an IP address, a proper IP address configured on a loopback interface, and it's being redistributed properly through the network, then you can always just use that to go directly to the router. You don't need to look up, okay, router ID 0.0.0.2, what is its IP address? You don't have to go digging for that. You say, oh, it's router ID 2.2.2.2. I'm just going to, SSH to 2.2.2.2 and talk to the router. There's other considerations that make loopbacks a standard choice. I would go so far as to say a recommended choice. There are some people that suggest you configure the loopback address and use the same thing in an explicit router ID command. Your mileage may vary. There's many ways of doing this, but that's why you have a loopback address there, is because that's going to serve as the unique router ID for the router. Now, does it have to be unique? Yes and no. Within an area, it has to be unique. Because if you have two routers saying, hi, I'm area 0 and I'm router ID 1, hi, I'm area 0, I'm router ID 1, there's going to be a massive conflict. So that's not going to work. Within an area, it must be unique. But when it crosses an area boundary, all of those routes are summarized into the new area. And so you do not technically need to have a unique router ID if they're in different areas. But if you have an autonomous system border router, or ASBR, it puts out a different type of link state advertisement, which is flooded through the network as is. And so everybody will see its router ID. So every ASBR must have a unique router ID. Now, I am giving you what is necessary. What you should do is make sure that every router in OSPF, no matter what area it is, make sure that every router has a unique router ID. It'll save you a lot of headache. It'll save you a lot of pain. Just make sure everybody has a unique router ID and be done with it. Preferably configured as a loopback interface so that you can actually use that as an identifier and a way of reaching the router if you need to. It'll make it a lot easier for you. Now, that covers why we have the loopback, and that covers why you need to have a unique router ID. Beyond that, this is fairly basic IP addressing. 10.0.0.1. We have it on a /30 subnet, and then we have 192.168.1.1, and it's on a /24. I should really not click there so that we can actually keep the drawing on the screen. And router 2 is similar. Then we have router OSPF 1. What does this do? The 1 in this case is just the OSPF process number. It is possible to have multiple OSPF processes running. You don't need to have separate processes running. And in fact, you can see here that we've got 2 different areas connected on both of these routers, and they're under the same process. So there's no reason why you need to have separate OSPF processes specifically. But you have the option to do so. If you want a separate OSPF process over here and a separate one over here, each processing different areas and different whatever, you can do it. The 1 is not important here. It's just the process ID for OSPF. And 1 is a typical number to use. Network 10.0.0.0 0.0.0.3 area 0. This is a standard network statement. This does 2 things. This says this particular network is a part of this area. It also tells OSPF to start talking on this network by default. There are ways that you can tell OSPF, I want you to listen but not talk. It's called passive interface. There are different ways of configuring that. I'm not going to go into that today because that would be way too much detail. We're trying to stick to basics here today. And then you have network 192.168.1.0, 0.0.0.255, area 1. So this is area 0, this is area 1, and this is area 2. I should have annotated the diagram with that, and I forgot. My apologies. So you can see that we're basically telling it that we're going to tell you what this network is, and we're going to tell you what area it's a part of. Cool. You cannot make a network part of 2 different areas. Because it just doesn't work that way. What I would recommend you do, and what I didn't do, but what I could do quite simply, is make sure that you have your loopback as, something that other devices can actually reach. Because again, if it's not mentioned here, then OSPF is not going to make use of it, and it's not going to advertise it. There are ways that you can do things like route redistribution. Again, an advanced topic I'm not going to get into today. And clearly on a loopback, there's no particular reason for OSPF to be trying to talk to itself, but you'll want it advertised so that the other router can actually see an IP route to 1.1.1.1 or to 2.2.2.2. So that is something that you can do. Interesting to note, and also important to note, which is partly why I have it listed here, when you're configuring an IP address, you're using a standard subnet mask, obviously. But when you're doing OSPF, you're using a wildcard mask. I would also call it a firewall mask, because that's where you usually use it. But it's technically called a wildcard mask. In a subnet mask, every bit in the mask, which is a 1, is identified as part of the host. And everything that is a 0, everything that's a 1 is part of the network or subnetwork. And everything that's a 0 is the host, the individual station on that network. With a wildcard mask, it's defined differently. Any bit, and remember these are bits we're talking about, any bit that is a 0 means that it must match. And any bit which is a 1 means it doesn't check that part of the IP address in order to determine whether it fits the filter or not. So in this case, if I'm using 0.0.0.255, it means that 192.168.1, all of that must match, but the .255 means it doesn't care anything about what's after the .1. So 1.1 will work, 1.2 will work, 1.50 will work. It doesn't care. So we're using subnet masks for your IP addresses and wildcard masks for your network definitions. I don't have a setup live right now where I can actually demonstrate to you that this works. To some extent, if you have the equipment, feel free to dump this in, test it out. If you have a simulator, I would suggest something like GNS3. I just haven't set that up currently myself. Or alternatively, gotten the stack of routers out of my closet and used that. But this is a very, very basic configuration, and it will work. Router 1 will see a route to 192.168.2. And router 2 will see one to 192.168.1. Because OSPF summarizes the routes from other areas and then broadcasts that through the area linking the other two routers, which in this case is area 0, the backbone area. Here's an interesting thing. There's conceptually some different behavior that OSPF uses depending on whether it's a point-to-point network or a multi-access network. And it's important to note that we're talking about the network technology, not the IP address. OSPF does not technically depend on IP addresses, especially because there's technologies you can use that use things like IP unnumbered. If it's unnumbered, it's just a point-to-point link, and you just throw whatever you want on the line because there's only one device that can receive it on the other side. Most of what you see these days is going to be Ethernet. Ethernet by default, actually never mind by default, Ethernet is a multi-access technology. That's just what it is. If you're on a serial link with IP addresses configured in a point-to-point configuration, A serial link OSPF is just going to form its neighbor relationships without issue. On a multi-access network, there's another step that takes place, and that is the DR-BDR election. Because Ethernet is a bus, a shared broadcast medium, whether you configure it with a point-to-point address or not, on the link, OSPF is going to hold a DR-BDR election. What are the alphabet soup? What is this? DR is designated router. BDR is backup designated router. Everything else will end up with a status of DR other. Okay, cool. The designated router and the backup designated router have a specific purpose, which is all of these link state advertisements are sent using multicast. They use a multicast address on the network. So, do we want 50 different routers on a single Ethernet link, all talking to every single one of the other 49? No, we don't. That would be way too much traffic. So, routers that have an update will send that update to the multicast address for all DR or all BDR routers. And so the DR, the designated router, will kind of collect all the updates from everybody and send a multicast update to all OSPF routers saying, here's all the link state advertisements. Everybody only talks to one or two, DR and backup DR. And then those two talk to everybody else through a single multicast transmission. Way simpler than trying to have 50 routers all broadcasting to everybody and establishing all of those adjacency relationships. So just that's what you'll end up on this particular link between R1 and R2. You'll end up with a DR and BDR election. One of these will become the DR, one of them will become the BDR. By default, all of these are priority 1. A priority of 0 means it will never be selected as a DR or BDR because the administrator has disabled it. If you want, you can choose a higher priority, priority 10 or something like that, for the device that you want to be more heavily weighted towards it becoming the DR. In practice, I don't think you're ever going to have a need for that. As a matter of fact, in practice, I don't think you're ever going to have more than 2 routers, possibly 3, on the same network link, all participating in OSPF. Where this might be different is if you're using something like I covered last week, MPLS. If you have 50 different sites that are all trying to do dynamic routing, and you have one WAN subnet, for lack of a better description, then yeah, you might have multiple routers all speaking on the same link, and they might all be treating it as Ethernet. If that's the case, then yeah, you're going to have a DR-BDR election, and you might want to make sure that your DR is in a main site that is well connected and not happens to be some branch office with only one connection where all the traffic has to go through. That would bottleneck your routing algorithm. So yes, there's reasons why you might need to configure priority. I don't think it's very likely that any of us will run into that anytime soon, if ever. But it's there, and it's something to know about. Now, you'll notice that we're using IP addresses or things that look like IP addresses but aren't actually IP addresses in the case of things like router IDs. And you'll also notice that I've talked about multicast transmissions. But here's another important point to note. OSPF does not use TCP or UDP or any of those other higher level network protocols. OSPF is its own protocol. It means there are no port numbers, because port numbers are a feature of TCP and UDP. OSPF is a separate IP protocol. It just runs in IP at layer 3 only. Doesn't worry about any of the higher layers. Does this mean that OSPF is at layer 4 or technically layer 7 because it's an application? I'm not going to get into that. You could argue either one of those, but it is its own IP protocol. It has its own IP protocol number, which means most of your firewalls out there, which are based on, is it TCP, is it UDP, what's its port number, OSPF will not make it through any of those because it's not TCP or UDP. It's a completely separate protocol. Most firewalls, if you're not specifying TCP or UDP, are just going to fall back to any IP traffic. All the protocols. OSPF is one. GRE, or generic routing encapsulation, is another one. Where do you see this? Well, one of the places you used to see this was in PPTP VPNs. PPTP being point-to-point tunneling protocol. Was very common with Windows Server 2003 and immediately following that. PPTP did use a standard port number to open a control connection. But once it opened that control connection, all of the actual VPN traffic traveled over a GRE tunnel, which is generic routing encapsulation tunnel, which, if memory serves, was IP protocol number 47. It's not TCP, it's not UDP. So if you didn't have a VPN pass-through feature on whatever device you were using, and you had an overly restrictive firewall, you could never get that connection through. It was a bit of a chore to deal with. And it's still a bit of a chore to deal with today. But I'm not going to go further down that rabbit hole. All I'm going to say is, if you're using OSPF on your routers, you'll want to be careful that you don't have firewalls getting in the way. If you do, you need to find a way to unblock OSPF's protocol, because it's not TCP or UDP. It uses no port numbers. There's no way to filter that except by the IP protocol number. So if your firewall doesn't offer the ability to filter by IP protocol number, you might be kind of out of luck. That's something that I don't have a lot of experience dealing with in terms of trying to punch OSPF through a firewall specifically. Like I said, I've tried doing it with GRE, and it's a massive pain in the butt. Typically speaking, though, I would say that your routers are not going to be heavily firewalled, except at a branch office site. Certainly in your demonstrations, in your practice sessions, in this particular diagram, there's no need to have a firewall. There's no real traffic being transmitted here, and a firewall is only going to make it more difficult to demonstrate what we want to see, which is that OSPF does talk to each other and can exchange routing information. So real world application in this day and age, where you need a firewall on everything that is internet connected, period, full stop, using some of these routing protocols is going to get a lot trickier, especially when it's not using the standard protocols that firewalls are mostly built to deal with these days. So that's another thing to take into consideration. That is most of the basic stuff that I wanted to show you today. There's way more that you can and should cover if you want to start implementing OSPF yourself directly. There are things like an authentication. How do you know that the link state advertisement wasn't spoofed by a malicious actor? You can put a password on it, or what functions as an authentication string. You can add that there. You could fiddle with your DR and BDR priorities. You could do that. You could manually set a router ID like I showed you. But I mean, if you have a working loopback, why would you? Excuse me. And if you wanted to, you could also get into some of the other redistribution topics, such as I have a static route, I have OSPF dynamic routes. How do I take the static route and put that into OSPF? Or maybe I have OSPF running internally and I've got ISIS or BGP running on another interface, and I want to take the routes that I'm learning from BGP and put them into OSPF, or I want to take the routes I'm learning from OSPF and put them into BGP. There is a lot, and I mean a lot, of complicated, extra, advanced stuff that you can learn about. And if this interests you, I would encourage you to dig into it, learn more about it. There's a lot there. And if you're going to be a network admin, it certainly helps, I think, to know something about it. Like I said last week, do I see us using OSPF? No, none of our clients use it. None of my clients that I do work for have a need for any dynamic routing whatsoever. It's just not something that's necessary. But knowing that it's an option, knowing a little bit about how it works, knowing something about what kind of problems or other risk factors you might run into along the way, all of it goes into expanding your knowledge about what things can happen along the way. And it helps your mind become a little more flexible in figuring out what works, what doesn't work, what works well, what could work but really isn't going to work well. There's lots of things that you can explore along the way, and I think it makes you a better network admin if you do know it. But it's not necessarily going to be something that you use every day. I haven't used it in 20 years. So take that as you will. Regardless, hopefully that was interesting for you, whether you're a hardcore networking admin or not. Either way, I hope you found it interesting, possibly even useful. If you have thoughts on anything else you would like to see me talk about, please feel free to let me know down in the comments section. And otherwise, thank you very much for watching. I am your next door net admin, and we will see you next time.